Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first two parts of the quadratic equation where I have explained the sum and the product of the roots of a quadratic equation, how to determine the nature of roots of a quadratic equation and so on. So if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to see the graphical representation of a quadratic equation. So let us start with today's video. The standard form of a quadratic equation is given by y equals to ax square plus bx plus c, where abc has some constant and a is a leading coefficient and a is not equal to 0. So that means if I'm putting different values of x, I'm getting different values of y. This quadratic expression ax square plus bx plus c is also called as a quadratic polynomial, which we also denote by f of x. So that means if I want to find the value of this quadratic expression at x equal to 2, say, in that case, I'll be writing f of 2, which would be equal to a into 2 square plus b into 2 plus c, which would be equal to 4a plus 2b plus c. Now, depending on the value of ABC, we'll be getting the value of this quadratic expression at x equal to 2. In a similar way, the value of this quadratic expression at x equal to -1 can be written as f of -1, which would be a into -1 square plus b into -1 plus c, which would be a minus b plus c. So we can find the value of this quadratic expression for any values of x, which could be denoted by y or fx. Now, let us consider a specific quadratic equation as y equal to x square minus 6x plus 8. And let us try to find different values of this quadratic expression or the value of y, that is fx, for different values of x. Now, I have tabulated some values of x and the corresponding values of y. For example, at x equals to -3, the value of y would be -3 square minus 6 into -3 plus 8, which would be giving us 35. In a similar way, at x equals to 0, the value of y would be 0 square minus 6 into 0 plus 8, which would be 8. And at x equals to 4, the value of y would be 4 square minus 6 into 4 plus 8, which would be 0, and so on. So in this way, we have got some different values of y for some values of x. Now, if we plot these different values of x and y in x and y coordinate axis, we are getting this graph. Let us see why. At x equal to -1, the value of y is 15. So -1 would be somewhere here, and the corresponding value of y is 15. That would be somewhere here. Similarly, at x equals to 0, that is at the origin, the value of y is 8. And at x equal to 1, the value of y is 3. That is somewhere here. In a similar way, at x equals to 2 and at x equals to 4, the value of y is 0. And at x equals to 3, the value of y is -1. In a similar way, at x equals to 6, the value of y is 8, and so on. So if we join all these points, we'll be getting this graph. And this graph has a name, and we call it as a parabola. Since this graph is pointing upward, so this graph is called as an upward parabola. In this particular quadratic equation, we have considered the leading coefficient, that is a, to be greater than 0. So that's why we are getting an upward parabola. In a similar way, if we consider the leading coefficient, that is a, to be less than 0, in that case, we'll be getting a downward parabola. That is a parabola which would be looking something like this. Well, you can consider a quadratic equation in which the leading coefficient is less than 0, and you can plot the points and draw the graph, and you will find that you'll be getting a downward parabola, something like this. Now, there are some points which we can observe from this parabola. First, at x equals to 2 and at x equals to 4, the graph value is 0. And if we know the values of x at which the quadratic equation attains a value of 0, those points are called as the roots of the quadratic equation. We can also verify this by equating this quadratic equation to be 0 and finding the roots. So if we equate this x square minus 6x plus 8 to be equal to 0, and if we try to factorize it, in that case the two factors would be x minus 2 and x minus 4, and this would be equal to 0. So the two roots would be x equal to 2 and x equal to 4. And from the graph, we can see that x equal to 2 and x equal to 4 are the points where the graph crosses the x-axis. So the roots of a quadratic equation are nothing but the points at which the curve crosses the x-axis. Now, another thing that we can observe from this graph is that when x was increasing from minus infinity to plus infinity, initially the value of y was a very big number. And when we kept on increasing the values of x, in that case, the value of y kept on decreasing and it attained a minimum value. And then again, when we increase the value of x, the graph kept on increasing and it attained a very high value again. The point at which the graph attained a minimum value is called as the minima point. And the value that the graph attained at this minima point is the minimum value of this quadratic equation. In this case, this minimum value is minus 1. In a similar way, if we consider a different quadratic equation in which the leading coefficient would be less than 0, in that case, we'd be getting a downward parabola. So in that case, we'd be getting a maxima point and the maximum value. Now, one thing that we can observe from this graph is that the graph behaves exactly in a similar way to the right side of this point as it behaves to the left side of this point. For example, at x equals to 4 and x equals to 2, which is at a distance of 1 unit from this minima point, the graph is attaining a value of 0. In a similar way, at x equal to 1 and at x equal to 5, the graph is attaining a value of 3. And at x equals to 0 and at x equals to 6, the graph is attaining a value of 8 and so on. So we can say that the graph behaves exactly to the left and the right side of this point. And this point has a name which is called as Point of Symmetry. And the line which passes through this point is called as the line of symmetry or the axis of symmetry. In this case, this line would be simply x equal to 3. Also, if we observe here carefully, we can find this point of symmetry simply by taking the midpoint of the two roots. In this case, the two roots are 2 and 4. So the midpoint of 2 and 4 would be 2 plus 4 by 2, that is 6 by 2, which would be 3. So the point of symmetry we can find simply by taking the midpoint of the roots. Also, one thing that we can observe from this graph is that except for this minima point or the point of symmetry, there are two values of x which is giving us the same value of y. For example, at x equal to 1 and at x equal to 5, we are getting the same value of y, which is 3. And at x equal to 0 and at x equal to 6, we are getting the same value of y to be 8 and so on. So this point of symmetry can also be found out simply by taking the midpoint of those 2 points of x, which is giving us the same value of y. In this case, we can take the midpoint of 1 and 5, which would be again 3, or the midpoint of 0 and 6, which would be again 3 and so on. So to find the point of symmetry, either we can take the midpoint of the roots or we can take the midpoint of those values of x, which is giving us the same value of y. So now, if we generalize this and if we consider the standard form of the quadratic equation, which is y equals to ax squared plus bx plus c, and we know that the two roots for this standard form of quadratic equation can be found out simply by using this formula, which is x is equals to minus b plus minus under root of b square minus 4ac upon 2a, where b square minus 4ac is the discriminant which we denote by capital D. So the first root can be written as x1 equal to minus b plus under root of d upon 2a, and the second root can be written as minus b minus root d upon 2a. And we know that the point of symmetry can be found out simply by taking the midpoint of these two roots. So the point of symmetry would be x1 plus x2 upon 2. So if we put the values of x1 and x2 and if we divide it by 2, we'll be getting the point of symmetry as minus b upon 2a. So simply by using this minus b by 2a, we can find the point of symmetry for any quadratic equation. We can verify for this quadratic equation as well. For this quadratic equation, the value of b is minus 6 and the value of a is 1. So minus b by 2a would be minus of minus 6 upon 2 into 1, which would be 6 by 2, that is 3. And from this graph, we know that x equal to 3 is the point of symmetry. So we can simply use x equal to minus b by 2a to find the point of symmetry for any quadratic equation. Also, at the point of symmetry, we get the minimum or maximum value of a quadratic equation. So this x equal to minus b by 2a will also be the minima point or the maxima point for a given quadratic equation. And we can put this x equal to minus b by 2a in this quadratic equation to find the maximum or minimum value. Now, for this quadratic equation, the discriminant d would be b square minus 4ac, which would be minus 6 square minus 4 into 1 into 8, which would be 36 minus 32, that is 4. So here we can see that the discriminant is greater than 0. So the roots would be real and distinct, which we can also see from this graph, where the roots are real and distinct, that is 2 and 4. Also, for those quadratic equations in which the discriminant is equal to 0, in that case, the roots are real and equal. So the graph for those quadratic equation would be something like this. That is, it will be crossing the x-axis at only one point, since the roots would be real and equal. In a similar way, if the discriminant is less than 0, in that case, we won't be getting any real roots and the roots would be imaginary. So the graph for those quadratic equation would be something like this. And we can observe from the graph that it is not crossing the x-axis at any point, which indicates that there are no real roots and all the roots are imaginary. Now, if we summarize all the points, we can see the standard form of a quadratic equation is given by y equals to ax square plus bx plus c, where a is a leading coefficient and a is not equal to 0. And the two roots of the quadratic equation is given by minus b plus minus under root of b square minus 4ac upon 2a, where b square minus 4ac is the discriminant. Also, when the leading coefficient a is greater than 0, we'll be getting an upward parabola. So in that case, we'll be getting a minima point and we'll be able to get the minimum value of a quadratic equation. In a similar way, if the leading coefficient is less than 0, we'll be getting a downward parabola. So we'll be getting a maxima point. So we'll be able to get the maximum value for that quadratic equation. Also, the maxima or the minima point or the point of symmetry or the line or axis of symmetry is given by x equal to minus b upon 2a. And if we put x equal to minus b upon 2a in this quadratic equation, we would be able to get the maximum or minimum value. Also, for a quadratic equation, if the discriminant is greater than 0, in that case, the graph of that quadratic equation would be crossing the x-axis at 2 points, which indicates that the roots are real and distinct. In a similar way, if the discriminant is equal to 0, then the graph would be crossing the x-axis at only 1 point, which indicates that the roots are real and equal. And if the discriminant is less than 0, then the graph of the quadratic equation won't be crossing the x-axis at any point, which indicates there won't be any real roots. So the roots would be imaginary. Now, let us take this question to understand the concept that we have learned. If fx is equal to ax square plus bx plus c is a quadratic polynomial such that f of 3 is equal to f of 6 and f of 4 is equal to 0, then find k which is not equal to 4 such that fk is equal to 0 and the ratio of f8 upon f1. I will show you two ways of solving this question. First, via the normal method, and the second one by using the concept that we have just learned a few minutes back. Here, it has been given that f3 is equal to f6. That means this quadratic polynomial attains some value at x equal to 3 and at x equal to 6, and both these values are equal. And this quadratic polynomial attains a value of 0 at x equal to 4. So, using f3 equals to f6, we can write a into 3 square, that is 9, plus b into 3 plus c equals a into 6 square, that is 36, plus 6b plus c. So if we simplify this, this would be 36a minus 9a, that would be 27a, plus 6b minus 3b, that would be 3b, and this c and c we can cancel. So this would be equal to 0. So from this, we can write 3b would be minus 27a. So b can be written as minus 9a. Again, using f4 equals to 0, we can write 16a plus 4b plus c equals to 0. Now, using the value of b here, we can write 16a, 4 into b. So that would be 4 into minus 9a. So that would be minus 36a plus c equals to 0. So from this, c would be 20. Now, for the first part, we need to find the value of k such that fk would be 0 and k is not equal to 4. So if fk would be equal to 0, in that case, we can write a into k square plus b into k plus c equal to 0. Now, using the value of b as minus 9a and c as 20a, this equation can be written as a into k square plus minus 9a into k plus 20, and this is equals to 0. Now, we can divide this whole equation by a. In that case, this would be k square minus 9k plus 20 equals to 0. Now, this is a quadratic equation and we can solve it to find the values of k. So, if we factorize this, then the two factors would be k minus 4 and k minus 5, and this would be equal to 0. So, the two values of k would be k equals to 4 and k equals to 5. But it has been given that k is not equal to 4. So, the possible value of k would be 5. Now, to find the value of f8 upon f1, we can simply find f8, which would be 64a plus 8b plus c, and here we can use the value of b and c in terms of a. So in that case, this would be 64a plus 8 into b, so that would be 8 into minus 9a, which would be minus 72a, plus c would be 20a. Now, if we simplify this, this would be 12. In a similar way, we can find f of 1, which would be a plus b plus c. Again, if we use the value of b and c in terms of a, so this would be a minus 9a plus 20a. So again, if we simplify this, this would be 12a. Now, we can observe that the value of f8 and the value of f1 is same, and this is 12a. So this ratio, that is f8 upon f1, would be simply 1. Well, we have got the answers, but it took us a lot of time to solve this. So let us use the concept that we have learned and let us see how efficient that approach would be. From the question, we know that f of 3 is equal to f of 6. That is, this quadratic polynomial attains the same value at x equals to 3 and at x equal to 6. And f of 4 is equal to 0. So we can say that 4 would be one of the roots for this quadratic equation. Now, for the first part, we need to find k such that f of k would be 0 and k is not equal to 4. So indirectly, the question is asking us to find the other root for this quadratic equation. We have learned one concept that the point of symmetry can be found out simply by taking the midpoint of the roots or by taking the midpoint of those values of x which gives us the same value of y. In this case, at x equals to 3 and at x equals to 6, we are getting the same value of y. So the midpoint would be 3 plus 6 by 2. And one of the root is 4. So let us assume that the other root is k. So the midpoint in this case would be 4 plus k upon 2. And we know that both of this would give us the point of symmetry. So this would be equal. So from this, we can cancel 2 and 2. So this would be 9 would be equal to 4 plus k. So k would be 5. So in this way, we can find the other root. Now, for the second part, that is to find the ratio of f8 upon f1, again, we can apply the same approach. That is, the midpoint of the roots would be same as the midpoint of those values of x for which we are getting the same values of y. In this case, the midpoint of the roots would be simply 4 plus 5 by 2, which is 9 by 2, that is 4.5. And the midpoint of 1 and 8 will also give us 4.5. So this indicates that the graph attains the same value at x equals to 8 and at x equals to 1. So f8 would be equal to f1. So the ratio of f8 upon f1 would be simply 1. So you can see how efficiently we can solve this question simply by knowing the concepts deeply. So that's why it is always advisable to solve such kind of questions in this way rather going via this process, as it is too much time consuming. Well, if you are facing difficulty to solve this question in this way, I would advise you to watch the concept part once again and then to attempt this question. So that's it for today's video, in which we have seen the graphical representation of a quadratic equation and some important points related to it. And in the next video, we'll be doing some problems based on quadratic equation. So I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of the queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in the next video. Till then, keep learning, keep sharing, and keep growing. Thank you.